Okay, let's get started. It's 12:20. Welcome to another clinic. Um, I have something prepared, but before I go there, are there any questions about anything HDF5? Any problems you might have? Um, Anybody? No? Okay, then we'll just dive right in. And I prepared something sort of following up maybe a little bit on the last episode that I did, sort of on some of the AI tools that are available now. I just had a little more playtime, and I think there are interesting things that they can do. And I'll just want to show you something that's perhaps a little less artificial than what I showed you last time, and not only less artificial, something that's eminently practical. And so the example that I chose was someone gave me sort of a directory filled with TIFF files. And okay, so in broad terms, the challenge is, okay, can I sort of stuff all these TIFF files into a single HDF5 file? And the answer is, of course, yes, you can do that. But then let's explore some of the different ways how you can do that. And in particular, we don't want to write that code ourselves. We want Chat GPT or one of those tools to write it for us. And then, so how do we guide it toward that goal? And so just for information here, so there are, in this case, 978 TIFF files. And if you look at an individual one, like 001.tiff, so numbering starts at 1, not at 0. So this is a TIFF file. It's 960 by 1003, so that's I believe that's width times height. And it's 2 bytes for the actual pixel value, UN16, and it's TIFF. Good. So we got a bunch of them. And throughout this tutorial, what I'm going to try to do is, of course, I ran all these prompts that I will show you through Chat GPT. And but I'll run some of them. Actually, all of them run actually pretty quickly, but then the programs themselves, some of them run faster than others, and we'll see how we are getting on. And so I will actually use a Python file that I call h5pystacker. So I always will take the response that I get from ChatGPT and paste it into that Python script, and then we'll just run it and to convince ourselves, yeah, that suggestion is working and what it really does. So let's maybe for a moment put this in a more eye-friendly form. Again, our goal is we want to create an HDF5 file that stores all these TIFF images in some form. And let's start perhaps with the most naive version, I would call it, where in terms of our prompt, so I put these markdown blocks here, these markdown code blocks, and in this case, the prompt, the question or the instructions that I will be giving ChatGPT are in such a code block. And the first time around, I will be very specific, sort of very detailed about what I wanted to do. And then later on, we'll relax that a little bit. So I will start out by saying, hey, I have a directory that contains 978 TIFF images that has 960 pixels width and 1003 pixels height. And each pixel is represented by 2 bytes. And I would like you to write a Python program that, number one, accepts a directory name as a command line argument, and that creates a new HDF5 file, and I'm going to call it v1 for version 1.h5 in that directory. And then while you are at it, please iterate over all the TIFF files in the directory. And for each image, write a 2D data set whose name is the file name without the extension, and whose shape is unsurprisingly height times width, because height corresponds in this case to the number of rows, and width corresponds to number of columns. And I'm very specific about the data type, which is UN16. So what I'm going to do is I'm just going to copy this prompt and head over to Chat GPT. And my Chat GPT window is here. And that's what I'm going to do. So let me make this full screen, and I will paste that message in here. And let's see what ChatGPT comes back with. And it says, I need all kinds of things. It's actually interesting. It changed its mind versus what it had this morning. Now it uses the PIL module. This morning when I tried this, it used the TIFF with 3 Fs TIFF file module. And so we'll see. I still have the response from this morning, but yeah, so let's try this. So we're going to take this copy code and head back to VS Code, paste it into our stacker here. Let's quickly look at what it's doing. Okay, create HDF5, that's our function. Our HDF5 file is going to be v1.h5. The file extension is .tiff. That looks all good. It concatenates all that. uint16 is the when it reads the pixel values, so to speak. That's the NumPy data type. And yeah, it constructs the name without extension and so forth. So superficially, that looks pretty good. So let's put it to the test. I'm going to head over here and I'm going to say Python 3, and what did I call this thing? H5 stacker, and then it's in the current directory. So dot, clearly doing something. Let's see what it did. Okay, so it created our HDF5 file v1.h5, and it's a little over, what is that? 1 gigabyte, sort of almost 2 gigabytes, 1.8 something rather. And that's cool. That's all uncompressed and so forth. And TIFF, of course, yeah, is uncompressed or TIFF. And so let's look at this with some of our HDF tools. If I do, for example, an h5 dump dash pbh on v1.h5, and that's going to be a long list. So earliest file format, all good stuff. Here's our first data set 001. It has the right type, unsigned 16, little endian. The dimensions look okay. It gives us the size. Cool. So we have 01, 02, and so forth. So that's all good. So that's what we asked for, and that's what we got. Okay. Good. So interesting first sort of footnote is, yeah, I got a slightly different response this morning, but it's good. It just uses a different Python module. I'm happy to share this file with people who are interested. So the code that I got this morning is listed here in my little markdown cheat sheet. Actually, Control Z, Control K, Z. This is the response, and yeah, instead of using the PIL module, it uses the TIFF file module. I also have seen the open image module being used, so I don't ask me how it decides the image sort of module flavor of the day. Cool. Next one is a softball. We just say, hey, we know that TIFF doesn't do compression out of the box, and so let's just modify this prompt and ask for compression. And the only thing we have to do is actually, rather than saying writes a 2D data set, we say writes a compressed 2D data set. I would point out that, yeah, we are not saying anything about which compression method or chunk size or compression level. Let's assume it uses GZIP, which is very likely. We are not specifying a compression level. So yeah, let's just see if we go back to ChatGPT, what it comes up with. Okay, sorry. Compress, right. You can use GZIP compression, very helpful. There are different compression levels, as it points out to us. And again, it's a softball. The code is exactly the same, except for when we create a data set, there's an additional keyword that specifies the compression method and the compression level. So very helpful. Let's just do this spot check, then I save myself. Yeah, so you see compression opts, and it uses 9, which is pretty aggressive. But yeah, today is not about compression methods. Okay, let's copy this and run it, and it should be fine as is. Let's see. Right. So we would expect this to perform just as well. So we create v.1.1 and .h5. So if we come back here and execute this, we should get a new HDF5 file, and we would like to see some effect of that compression. Of course, yeah, the runtime will be a little higher because yeah, doing the compression is going to take some time, and that's all cool. By the way, we are still at the stage where we store each image individually as a data set. And that's actually what we will look at next. People might say, well, ideally, we would take this stack of images and put these images sort of as hyperslabs or frames into a 3D data set, and we'll do that next. Okay, here we go. Let's do a listing here. So we got our file. It is shaved off maybe 500 megabytes, which is respectable. If you look at the size difference between the v1.h5 and the v11.h5. So pretty good. Next, so let's go back to our cheat sheet here. And again, yeah, the only difference this morning was that it uses a different Python module. And yeah, so version 1.2, let's try and get it to write the individual images as hyperslabs to a single 3D data set. And the way we are going to try to sell this to ChatGPT is basically, we keep our sort of sermon up here, but then we say, okay, we also throw in, well, please use the latest file format version, so to speak, containing a 3D data set called pixels. That's what we call it. And again, we are very specific about the shape of that. It's going to be, since we have 978 images, this is going to be a 3D data set like that. And then as you are iterating over these TIFF files for each image, write a 2D hyperslab to the pixels data set. And this is already interesting because, again, as humans, I think we would understand that, yeah, I don't want it to write a hyperslab, a 2D hyperslab at position 0, and then subsequent hyperslabs pretty much override this. That would be silly. And as humans, that, yeah, is kind of a foregone conclusion for us. But I didn't explicitly say, okay, keep moving on with that hyperslab along the slowest changing dimension and so forth. So this could be a whole lot more verbose. So we leave that to ChatGPT to do what's in double quotes common sense. And so let's take that and sorry, I don't have that control. Okay, I'm getting confused here with my Emacs keystrokes. Okay, heading back to ChatGPT. Here you go. We want a 3D data set, so let's see what's going on here. Okay, it tells us that we can do multidimensional arrays, hyperslab, all good stuff. First dimension, assume the order of the images. So yeah, that's what we intended. And it's still sticking with PIL. That's cool. And we see, yeah, it's creating a 3D data set. It uses len of TIFF files, which was this list of TIFF file names. So definitely it picked uh, the right dimension there. And it's actually interesting because we told it 978, but nevertheless it went out and said, well, yeah, I can count, I can figure out how many images there are and then make that the leading dimension, the slowest changing dimension that is. And yeah, file name 1.2. So let's just try this. So I'm going to copy that code and come over here, override this version of the code, and yeah, let's just run it and see what we get. And that's going, and it was pretty fast. And let's just show the HDF5 files. Right, so we have size-wise version 1.2 is just a little shy of the version 1, which really took individual images and stored them as two-dimensional data sets. Now, yeah, call it the metadata overhead is a little smaller here, so I'm not surprised that that one 3D data set is a little smaller. And we use the latest file format version, so there are some additional optimizations here. So pretty good. I mean, and let's just do a spot check here with H5 dump to see that it indeed did what we asked for. But according to the code, that's what we expect. So we have, oh, actually, for this one, we didn't specify the latest file format version. I take that back because Superblock version is 0. But we have our data set pixels in here in the root group, three-dimensional. It has all the right sizings and so forth. So pretty good. Now, let's maybe switch gears. And so in terms of our, if I go back to my cheat sheet here, both versions 1 and version 2, 1.2 were sort of pretty specific about specifying all these dimensions and so forth. But hey, that's just tedious because I mean, we know that all the images have the same width and height. And sure, we want to help Chat GPT, or we can tell it that, okay, all these images have the same size, but you can figure out by just opening the first image what the width and height should be. And obviously, we saw that already. You can count how many images there are. So let's be a little less specific on the on the whole counting and spacing business. So here, right, we are asking, is that really necessary to specify the dimensions? No, it wouldn't be necessary for humans. And let's be less specific about the TIFF images. So including, I'm not going to tell it these are 2-byte pixels. So the pixel values are U in 16, and so it can figure that out on its own. So here's the prompt, same introduction, and I give it the clue. They're all of the same width and height. And yeah, so we call that version 2. And so let's take this and let's head over to Chat GPT. And okay, here you go. And we want version 2. Okay. It uses GZIP. I forgot already. Did I ask it for? Oh yeah, I asked for compressed. Unlike the first version 1, where we did uncompressed, we include compression from the very beginning. And okay, so that looks cool. Again, let's see where it determines the the size of the data set, NP image, okay, image path. Let's see, where does it get the shape? I mean, this is just a NumPy array. I guess when the image class, I mean, the image class knows that it's as pixel values, a two-dimensional NumPy array and so forth. But yeah, we'll see that in a moment. No, I haven't copied it. So let's copy the code and go back to our stacker here. Select this. Cool. Let's run it. And so it's compressed. So we would expect something similar to version 1.1. And I forgot, it's probably GZIP compression again with level 9. Yeah, that's what it is. So that should be pretty close. Okay. Takes a little longer. Oh, here we go. Okay. And okay, yeah. Size is pretty much exactly the same as it should be. So we have our version 2, and just sort of a quick spot check here with H5 dump. Right, we have 0, 0, 1. Here's our compression ratio. It shows 63 by 120 chunks. Again, we didn't specify anything about chunk sizes, and we'll come back to that in a moment. And it did its thing, pretty decent compression ratio, done. Good. Okay, so moving along. Now, let's see if I do a Control-K-Z. So that went well. How about if we do the same thing that we did earlier, which is that, individual 2D data sets for images are great, but we really want that stack, that three-dimensional array. And so let's put this into a 3D data set. And so the prompt is pretty much the same, except for that, we don't talk anymore about this is the width and this is the height and so forth. It can pretty much figure that out on its own. Z. What's going on here? Control-K-Z. Okay. Yeah, I think I copied that. Okay. Let's put that in here, version 2.1. Yeah, okay. Let's run this. Yeah, so it basically repeats what we said, which is all images, same dimensions, order of images based on their lexicographic order in the directory listing. And that's all cool. So it figured that out. And yeah, I could almost skip this, but let's just run it for the fun of it. Right. Yeah. Good. So let's just, for completeness, run this. And let's see, we go over here. And that's all good. So run this. And just wanted to see, does it have the right file name 2.1? Yes. Oh, here we have a problem. Let's see, what's the problem? Could not broadcast into shape. Huh. Interesting. I did not have this problem this morning. Oh, right. So it doesn't do the, that's interesting. It doesn't do the hyperslab selection. Um, uh, let's see, and here's my reminder. Um, let's see, data set. I think I need sort of the comma, colon, comma, and ends with TIFF and dataset index, right? That's interesting. I did not have this problem this morning. Well, let's try this. Maybe it mixed up. Oh, there is something, somehow the height and width, it says could not broadcast input array from shape into, so somehow it flipped dimensions here, but height times width, that is actually correct. And I'm a little surprised here, but I'm not going to spend much time debugging this here. Yeah, somehow the dimensions are switched. Maybe if I do, I mean, that would work. That would not be what we want, but just one more try. Otherwise, I'll move on. Yeah, so this wouldn't have the right layout, but just to make it work, I fake it. Right, and the size, so we are talking version 2.1, right, it's the uncompressed, and that's all good. And just for completeness, let's look at version 2.1.h5. Yes, we have a single three-dimensional data set, and yes, I think these width and height are sort of mixed up or transposed, and that's okay, but we are not going to worry about that here. Let's do, I think I have two more. Let's quickly look at both, but I'm going to pick one because we are running out of time. Let's see. So one would be to turn on compression, and then another one is actually the more interesting one. I think the difference between version 2.2 and 2.1 is 2.2 and 2.2.1 is that here I just tell it, this is the three-dimensional data set, I tell it to turn on compression. So what it will do is in H5Py, it's going to create three-dimensional chunks that are sort of cube-like, call it that, or sort of, yeah, that are not individual images as chunks, or not too skinny, not too high aspect ratio, so to speak. But in this case, what that means is that the performance is terrible, the write performance and also the read performance. And because there's also compression on top of that, which slows things down already. So what you have to do is to manually intervene pretty much and tell it that makes each image a separate chunk. So with that, so what I'm going to do is I'm not going to skip 2.2 and skip right ahead to 2.2.1. Is let's just jump over here and put this prompt in here and then ask it to create that for us. And what you can see is, right, creating empty with chunk size, image dimensions, and use NumPy slicing to write data into the data set. And okay, that's cool. Right, so here we see under chunk already, the chunks are 1 by height times width, and that's exactly what we want. So if we give this one more roll of the dice, so to speak, let's save this and try to run it. And that should be pretty fast and in line with what we saw earlier. And yeah, so whereas the other version, if you don't specify in this case the chunk size explicitly to be an individual frame, it runs for several minutes. I forgot I didn't time it, but it takes a long time. And okay, it's going to be done momentarily. So while this is completing, are there any questions, comments, thoughts? Again, the goal here was to show that taken, I think, eminently practical problems, such as somebody gives you a stack of TIFF images, oh, here we go, and you would like to write a quick, small utility. Yeah, so compression is here, and it's, yeah, let's just do one more H5 dump to convince ourselves that 2 point, what's this, 2 point, yeah. So yeah, the chunk size is 1,003,960. So that's the right chunk size. All good. Yes, so writing a small utility like this, yes, you can spend a lot of time if you want to. And if you are a beginner, might be time well spent. But as a busy professional, Chat GPT is pretty much all you need at this point, and it will get you off the ground quickly. And that's all I had to say. Any questions, comments, thoughts? No?
Oh,
Okay.
Gerd, I'll
Yeah.
just weigh in. That's amazing. That, I mean, this is just out of the box, but in terms of being a really good assistant, and the way it's able to sort of makes these what I consider remarkably sophisticated decisions, really, really impressive for just for where we are. That's, I mean, it's very useful if once properly integrated into if you think of it as a compile, edit, debug cycle for an HDF5 programmer, once it's really part of that loop, the way it's really malleable, that's impressive. It's like we're getting a glimpse of the next 20 years here.
Oh yeah, well, 20 years is a long time.
Well, it's just at the outset, we're at the very start of it, but and I don't see it as a replacement for a skilled a person very knowledgeable in HDF5 and the finer points of it, but just it's so conversant already in HDF5. It's impressive.
Mm-hmm.
So thank you for that, for all the work in that display, because I don't do too much with Chat GPT. So the insight that this provided was very helpful. You know, it takes away a little bit of the hype because you can see what's really going on.
Uh-huh,
So
uh-huh.
it's encouraging.
Yeah, yeah, yeah. What I can also say, and maybe I can, if I get another chance to do one of these, I will try to pick up also when I did this in Visual Studio Code, I use GitHub Copilot. And to me, some people maybe have a preference for one or the other. So for example, can you create this code in Copilot alone? Yes, you can. However, what I found interesting was really this interplay between sort of developing the prompt in Visual Studio Code with some help from GitHub Copilot already, because as I was typing the markdown, it was already proposing all kinds of completions and whatnot, not writing code, but just sort of in the rudimentary prose that I was writing. And then taking it over to Chat GPT and bringing it back. And so maybe next time I can show a little bit what I find intriguing is how sort of two such assistants try to be helpful in their own way. And
Yes, it changes the definition of manual labor the way you go back and forth between the two, but I'm assuming eventually all that will get sorted out in the development process. But yes, that's an area that's also a very interesting one for development. How to really make that very fluid for the programmer. So, but at this point, it's still really cool.
So Gerd, I don't remember, did you tell it to use Python? Did you tell it what environment you were in, or did you
actually, I don't remember. I don't believe so. Let's see if I go, I'm not going to share my screen again, but if I jump back to the beginning, oh yeah, I said in my first prompt, I said, write a Python program. But I can tell you that had I not specified that, Python is kind of canonical. I think that's where it starts.
Yeah.
But if I were more deliberate about C or C++, then it would do that also.
Yeah. Well, actually, I just wanted to tell you towards the end there, while you were doing that last example, I went to Chat GPT and I typed in, well, actually, let me share my screen here. If I can find this. Yeah, there we go. I said I have 978 TIFF files. Each file contains an image with dimensions 103 by 960. How can I extract these images and store them in a single HDF5 file? And it gave me essentially the same answer that it gave you. So I didn't even have to, you know, it told me which libraries to get. It suggested Python. So, you know, it's just phenomenal.
Yeah, it's pretty impressive. And yeah, so I was using, you are using 3.5, and yeah, for certain purposes, the difference between 3.5 and 4 or some of these versions might be significant, but for these mundane tasks, so to speak, it probably makes no difference.
Yeah, it's amazing.
You know, whereas if you bring your legal case to Chat GPT, there might be a big difference between 3.5 and 4. Yeah.
Cool.
Okay, cool. Then, well, thanks very much for coming, and enjoy the rest of your day.
Okay, thanks, Gerd.
Yep.
Thank you, Gerd.
Yeah. Bye.
Bye.